In keeping with the theme of stills to back up work that I've done, here's that same set as I got it. Unfortunately, the CRT was bad in it, but I didn't know that at the time. Here I am starting to work on it. The chassis was incredibly rusty. This little flyback uh, cover, completely covered in rust. I ended up using an electrolysis approach to remove the rust and remaining paint. That's just putting it into a solution uh, and putting a couple electrodes between the case and a sacrificial anode in the same solution. It would boil off the paint and rust, and got it pretty clean. I didn't paint it with some gray primer and just left it at that. Here's the chassis. You're looking at it, there's a flyback. It's in pretty good shape. The picture's a little blurry. I don't think I've done very much with it at this time. You can see these caps right here. That's called a bumblebee cap. That's in the horizontal circuit. That's one of the typical kind of caps that you always have to replace no matter what. They're always bad. You probably sell them to the vintage audio guys, and they like those leaky caps. I think it makes your amp sound weird. Here's a picture of the chassis. Just a top shot, and this you can see that there's no paper caps on this. I'll try to get a little closer. All these capacitors are what they call brown drops. There's a bumblebee cap right there. Here's a couple of these white Elminco style caps. Let me get my pointer, might be a little bit easier to work with. A lot of rust on the tuner, or the big paper caps in the video circuit. There's a electrolytic cap. Here's a close-up of the flyback. You can see those big bumblebees. Actually, the flyback looks to be pretty good in this set. You can see it had quite a bit of rust. It was a real mess. Oh, this is me. This is a cathode current reading I was doing when I was testing the setup of the horizontal. There's a couple adjusting coils in the circuit, the damper circuit. There's something called an efficiency coil that you can tweak, and the idea is to get the minimum cathode current running through the horizontal output tube. It's good for life of the tube and the flyback and in general health of the system. Here I am checking some high voltages. Not much there. There's an early shot of it. This is it running through a test jig. The test jig has a pretty weak CRT, and you know this is the first. I think that was the very first screenshot I got out of it. Here's some work that I'm starting to do. You can see there's been some capacitor replacements here, here. This looks like this is the chroma section. These RCAs, early RCAs didn't use PC boards in the chroma sections, and I go through and test the capacitors out and see if they're leaking, and then replace them if they are. I think most of the brown drops, again, this is a brown job, were bad in this chassis, so I ended up replacing a whole lot of them. You see some yellows. That's one because I probably ran out of good caps. I typically don't like to use these yellow Chinese caps. Here's some new era caps. Those are higher qualities. There are still some orange drops. I left them in there. That brown drop is okay. This is after testing and replacing all the bad caps. Here I am again. Oh, there's that coil I was talking about that was all kind of knackered up. Not very pretty. That's the efficiency coil. You can see I'm replacing capacitors there. This is an important cap to replace here. This is a feedback cap from the AGC that goes to gives the AGC. It's a keyed. That's it. It's a keyed AGC, and it uses a spike from the flyback. This flyback provides a spike that turns on the AGC tube, so it only samples the signal strength during the sync pulse period, and There's a big explanation behind that, but basically keyed AGC was kind of a new thing to make the sets less affected by things like airplane flutter. Of course, none of this matters anymore. All this technology is pointless, but today that was an important thing. Here's another replacement cap. So I'm just going through replacing caps. That resistor was bad, remember that. What else? You should always check power resistors. This power resistor probably goes pushing a lot of power through it. There's a good chance that it's maybe been overheated. This is the horizontal board. This little resistor right here, I hope you can see my mouse, right here, that was the culprit that I was talking about before. That resistor connects across the horizontal adjustment hold coil. This doesn't use a pot, it uses an adjustable coil for horizontal hold. It's just basically a setting for the horizontal oscillator, and that coil had drifted like, I think it was like 500% off. That's what a blue 68K, I think that was reading on the order of like 500K or something like that, and that made the horizontal setting extremely critical. You only had a good range of about an eighth of a turn, and typically you should be able to turn those coils several turns before losing sync. Anyway, that resistor was bad. It just had a bumblebee here. That's a fairly precision cap. It goes across this sine wave adjusting coil. I don't remember what else was on. You can see I put some new caps. Here's another new cap. I left this domino alone. It tested fine. Couldn't see any reason to replace it. This was a replacement. Here's a disc cap. I left it alone. Again, didn't seem to need a replacement. I'd rather diagnose problems rather than just shotgun replace. I just find that more satisfying. Vertical boards always have a lot of cap issues. I don't know why, but they seem to always have problems. I mean, you can see the number of caps replaced. Cap, new cap, new cap, new cap, new cap, new cap, new cap, all over the place with the caps. A lot of caps in a vertical board, and I always use really high voltage ratings. They're much higher than the original ones. If it had 1,000 before, I'll put a 1,600. If it has 1,600, I'll put a 2,000, just for an extra safety margin. Just some more work. That's the IF board. This had a bumblebee right here. People who work on 7s, 5s, 9s. This IF is under a shield. That's what these holes are all about right here. Got to always remember to remove that shield because there's a cap in here, and I think it's an AGC cap or something like that because it's actually a shared tube duty. But they always have bumblebees here, and bumblebees are always bad. So you want to go ahead and pull that IF cover off and check for that. These are audio. I think it's the audio part. Yeah, there's a couple of caps in here. I think again had a couple of bumblebees in there. Here you can see that electrolytic. That's part of the video board. That one was replaced. Electrolytics typically are bad. At least the single sections are anyway. It's been my experience. You can get an idea just how nasty this thing was when I got it. I'm going to get a close up. You can see just crud and junk. This was like in somebody's kind of a semi-outside shed. That thing was just rusted. That's the convergence board. This is a 21 CYP22, which is somewhat not a real rare tube, but it's definitely, you know, more rare than your standard 21 FJP. It's the dual anode type tube. Had great emissions on two of the guns. One of the guns, the filament would not light up, and I tried tapping the neck, holding the thing in different positions, hoping that maybe there's a broken weld or something like that. Never was able to get anywhere with that. So it's got two great, very strong guns and one completely dead gun. How depressing. Anyway, you can just see, I mean, there's like cobwebs in here and just, ugh, what a mess. I think I paid 25 bucks for it, so I don't feel too bad. And we're back to the beginning. Anyway, this complements the video that I also have on the same set with it running. Thank you.